Hello everyone, today we'll talk about the solution to the problem, different ways to add parentheses. We're given an expression consisting of non-negative numbers for our convenience so that we don't have to deal with leading negative signs, and operators, so addition, subtraction, multiplication, and there are no parentheses. And now there are some ways of adding parentheses, so of determining the order of operations. And you have to calculate for every possible order of operations in any order. We can think of those orders in any order. We have to calculate the result of that expression. So, in essence, when we have something like 1 plus 2 times 3, then we can either put parentheses here and, of course, at the end put them there, or we can put parentheses here and get two different results. Maybe some results will be possible to get multiple times, and we have to report them multiple times. So we can think about maybe how to represent the situation we're given. Maybe you know that this expression, this evaluation may be seen as a tree where the leaves are numbers, so let's say 1, 2, and 3. And now here we have those internal nodes as operations, as operands, operators. Oh, those are the operators. So here is a plus, here is a multiplication. And that corresponds to, we first add 1 and 2 together, then we multiply the result with 3. But it's not necessary to even think about that, because since in this problem we have to enumerate all the possible results, then the solution will be exponential with respect to the values that were given. And that means there is probably a short, maybe not that easy, but a short backtracking or recursive solution that we can implement. It's important to not get overwhelmed when something like this. Well, how do we think about adding those parentheses? How do we think? Well, the most convenient way, I think, of thinking about this is just that we have an expression or sub-expression of an expression, so maybe only those two values or something. And we have to decide which so we have to generate all the possible results from that sub-expression. And at the end, generating all the results for the full expression is our result. And to do that, we just have to first decide, so go over all the possibilities of which operator will be the last, so the top of the tree, in a sense. And then generate all the possibilities for what remains to the left and to the right. So again, we have A plus B times C minus D. So we have to decide if we want to start with the plus, with the times, or with the minus. And let's say we start with the times. Then we have, or maybe for a more interesting situation, let's start with this plus. So to the left we have only one possibility, an A. To the right we have two possibilities, B times C and then minus D, or B times C minus D. C minus D happens first. And then we have to take a cross product of both of those possibilities. So maybe we have Z plus A. So that also doesn't give us many possibilities. So we have to take a cross product. So for instance, if we have some options, so this is option 1, option 2, and so on the left hand side, our operator is plus. And now we have like option 1, option 2 on the other side, then all the possibilities have to be taken into account, because all of those correspond to a different order of operations. And so we just have to implement it and probably try to make that implementation succinct and easy to read. So the heart of the solution will be this recursive function that will get all the results for a given sub-expression. We'll start by taking the sub-expression from 0 to the end. That'll going to be our result. And of course this will recursively call itself on the left and right side. The probably most convenient way of actually storing that expression is to split it over everything that's not a digit. We use the split from the regex module because the standard Python split in string is useful when it's useful, and sometimes it's not useful. In this case, we want to split over a couple of different separators, and we also want to keep them in our split To keep them in our split, we have used these parentheses here. So this is everything that's not a digit, we keep it within, so then after splitting we get 1 plus 2 times 3 minus 22 and so on. So everything on positions that are even, 0, 2 and so on, is a number. Everything on an odd position, so 1, 3 and so on, is an operator. And then we also want to know how to translate operators written down into operators that can actually operate on values in Python. We can use the imported by default in LeetCode functions from the operator module. So now we're ready to implement our recursive function. So here is the base case when there is only one thing in our sub-expression. So that one thing has to be a number, so we just convert it to an integer and we return it as the only option, so within the list. Otherwise, we'll generate all the options based on the position of the first operator that we use. So the first operator is either first plus 1 or first plus 3 or first plus 5 and so on. So we have to step over all the odd numbers within our sub-expression with the step size of 2 to get all the odd numbers. And now we get from first to and not including the operator, and from what's to the right of the operator to the end. Those are those two sub-expressions that remain. We can generate them by recursing with the same function. And now, when we have all the options for the left-hand side, all the options for the right-hand side, we can use product from itertools to generate their cross product. And if we don't have this, then we can just have two nested for loops, because this is a simple case of a cross product of only two sets. So we generate that cross product, we iterate unpacking it into left and right hand side, and we try to get our operation actually calculated on those values. So we look at our lookup operators dictionary, and the operator that we have to use is defined by what the expression is on the position of the first operator. We append it to the current result, and at the end we return the current list of all the possibilities of results that we can get by evaluating in all the different orders in this sub-expression of first to last.